Welcome everyone to the next in the startup webinar series from DuploCloud, Navigating DevOps Hurdles, Practical Solutions. Today, we are joined by none other than the Adam Burns, Senior DevOps Engineer at DuploCloud. Adam, let you introduce yourself.
Yeah, good to see you all. I am a Senior DevOps Engineer at Duplo. I work on our onboarding team, which is the group that helps people get from wherever they are to on the platform. So I work with a wide range of projects. There's kind of no limit to what we do in the DevOps space here. So I see projects across a lot of different cloud providers, a lot of different application spaces, and ultimately getting them all onto whichever cloud provider they're looking to go to using Duplo. So I see a broad range of projects.
Awesome. And I am Cameron McDougall, Technical Marketing Engineer at DuploCloud. I am formerly I formerly did what Adam does, except I'm not quite as cool, but I used to be a consultant in DevOps. I've done MLOps and now on the public facing side. So before we get started, I want to call out our next in these webinar events. Next up, we've got Kelly. He's going to speak about CI/CD. We've got one about compliance and security, and then scaling DevOps. They're going to be great. Kelly's awesome too. So really hope to see everyone there. Put them on your calendar. And let's see, before we begin, we've got a Q&A little function over in the side somewhere. I don't know which side it's on, but it's make sure that you put your questions in there. We'll address those at the end. If you've got any other questions, then put them in the chat. I want to see the chat pop in today. Let us know what you're thinking, questions you've got, thoughts, insults, whatever you got, throw it at us. And with that said, let's dive right into the 6 often overlooked DevOps hurdles.
Yeah, so we're going to come at this from 3 main categories. The first one is scaling out that DevOps function. There's a couple of common areas where things tend to stall out when you're trying to get started or when you're trying to really add more folks and more bandwidth to the DevOps work that you're doing. So we'll look at a couple of tactics to get around those kinds of things. Then we'll jump into today's hot topic, security, across the whole industry. We're going to look at 2 specific things. One, an area where the access that you have to give to your deployment automation can come back to haunt you, and some modes of thought you can use for dividing up your infrastructure and your system into architectural components that can help you decide where to put security and operational boundaries. And then at the end, we'll look at a couple of kind of common anti-patterns that I run into that make applications just more difficult and more expensive to deploy.
Awesome. And the first one is scaling the DevOps function, never-ending planning cycles. I've been there. So Adam, tell us about how to handle that.
Yeah, so especially as you're scaling up DevOps, as you're deploying more infrastructure, the problem is that space has become really large. So there's a lot of decisions you'll have to make around what tooling to use and what patterns to follow. And this is a really common area where teams can stall out in trying to plan and approach through all that. Before I get into the tactics I use to get around that, I want to call out that I've seen a lot of teams succeed in a lot of different ways, and there's no right way to do this. This isn't these aren't best practices. They're tools and tactics that you can use to help get a team unstuck if they are stuck. But if they're going through their planning cycles and they're shipping outcomes and things, there's not necessarily a need to apply these tools. The overall principle that I try to follow when planning outcomes, or when planning gets stuck, is that the goal of planning is not to define detailed technical outcomes. It's to make sure that engineering hours aren't wasted. And the first approach that I use is to start iterating right away, even if I don't have a complete plan. When you're trying to anticipate future problems, you have too vague an understanding of what might go wrong. For example, I was working recently, I had some CloudFormation that someone wanted to retire. We're going to migrate it to a new automation system. And I was going through it and making sure that the new system we were using, the new pattern, would support all the things that the old system had implemented. And while I was digging through all that, I found a second load balancer that was used for specific clients. It served the same application, but it had different settings and things. And that seemed fine. That was all possible in AWS and everything. But when I started actually implementing that in the new system, what I discovered was that the module I was using just didn't support that. There wasn't a way to define a second load balancer. It was a wrapper that had some intentional simplicity in it that made things easier, but the consequence of that was you just couldn't put another one in place. And so I had to kind of pause, go back, switch to another module, and that did support that and then move on. And so, yeah, I had to go back and redo some work, but also because I was hands-on with the problem, I had all the details. I was close to it, and I could use that knowledge to find a good solution. If I had tried to identify all that kind of stuff before even starting in the planning phase, I mean, I wouldn't have known specifically to look at the load balancer, config inputs to try to find that. I would have had to go that deep on everything, on the security groups and the IAM roles and the RDS settings and all the other things. And I still might not have found it. Like, that's a pretty nuanced thing, like recognizing that the config structure of the tool doesn't let you define a second load balancer. Like, you'd have to audit pretty deep to catch that. You could spend weeks on it and still maybe not get it. So it's generally better to have a good understanding of the direction that you need to go in, but not necessarily try to audit to that level of detail, even if it means you're going to have to do some re-engineering on the way. It is still worthwhile to try to account for nuances like that in advance. I'm just saying time box it. Like, the goal is to minimize wasted hours, not to define complete technical outcomes. So you want to focus on setting that direction, but leave the details for iteration. So directions are things like, do you want serverless Lambda apps versus containerized Kubernetes apps? Details are things like those, how many load balancers can you put in front of the same service?
Definitely. And I think as long as you, like you said, time box, plan for needing that time at each step of the way, give yourself some hours so that you can really dive into the load balancers or Lambdas or whatever it is, and make sure that you have the time to really look through the documentation, figure out those details, and you should be fine. So just channel your inner Shia and just do it.
Yeah, there is a strong element of that. Like, the closer you can get to the problem, the better. So get in there, find something you can work on, even if you're not 100% sure. And the plan will start to fall out of the things that you discover as you're working on implementation.
Definitely. And I always really like those moments where, during a project, you can take some time to really dive into those details. It's kind of fun, every now and then you get a break from the stress and just figure things out. So.
Yeah, absolutely. The second tactic I use is to look for work that can be done right away, that will have to be done no matter what, so you can do it right away. There's almost always some work that will have to be done right away. And a common anti-pattern, though, is to try to plan first, like to get the plan done and then start iterating through the plan. But the negative side effect of that is that you end up holding up work that could be done right now. And if it can be done now, you might as well start it. But also, like you kind of mentioned, planning can be an exhausting, a high-pressure job. There's a lot of ways for it to come back to haunt you later. Every decision that you make poorly, you have to re-engineer. And it's tough to just do that. So getting folks working on code minimizes the amount of their day that's spent only on that one thing, that planning, and it helps manage stress. It also gives the team a chance to bond over like tactical successes and individual deployments and individual PRs, instead of constantly trying to negotiate more decisions. Even if the team works well together, negotiating decisions is hard. It has a lot of overhead. And if you don't spend your whole amount of time on that, it's going to make it like easier for the team overall. It also lets you see the quality of the work of new engineers before you rely too much on their planning recommendations. Not every engineer is a good fit for every situation, and it's a lot easier to see that by looking at the quality of hands-on work in your specific context than it is just through discussion and planning. So for examples of things that can be done right away, like I was working with a customer that was running on a deployment platform that was not Dockerized. They took your application artifacts, like your jar files or whatever, and they would run that directly for you. But this team had decided that they wanted to move to Dockerized services on Kubernetes. So no matter what, we were going to have to write Docker files that could build containers that would run their services. Separate from that, there were also open questions about like how many AWS accounts they need and what do the segmentations need to be, because they hadn't figured out all their like data classifications related to compliance and everything. So there were open questions about some of those things, but we had to write those Docker files no matter what. So we could get started on that immediately, while in parallel getting the meeting scheduled with leadership and stuff to plan out the AWS account structure. In contrast to that, I worked with another team that they were considering going to Dockerization in prod, but they weren't sure. That was still an open question. The thing was, their existing prod was in, like, it was mixed in with their pre-prod resources, and there were some security boundary issues. It wasn't locked down reasonably high enough. And so they needed to deal with the security problem in prod right away. And the Dockerization could wait until later. So we started lifting and shifting that out of the pre-prod environment into a dedicated prod environment straight away. So there's no script to find these things that you can start right away, but they're almost always there. And if you look for them, that will give you a way to move on to engineering and kind of do some of the planning in parallel.
Man, we could have used this back on one of the teams that I was on. We were rebuilding our entire infrastructure, and we got stuck with endless cycles in naming. We would spend hours every week talking about naming and naming conventions and what to name things so that we didn't run into problems later. to the point where like me and one of my teammates, we would just like be messaging on the side, like to ourselves, like just name it cats, the internet worships cats. So just name it a cat. We were just kind of having fun, but it's, I don't know, Adam, what would you say is something you can do when you have a team that's very stuck in planning to kind of get yourself out of that rut and start doing?
Well, if it's naming, then the canonical solution to that is to use fruit. I have plenty of apple and orange and banana environments. Like that's the solve to that one for sure. So what I do is always try to bring it back to the product in some way, especially something like naming. Like if you're in the startup phase and you're scaling out your DevOps function, that means that you're relatively early in deploying things, which means that you probably don't have that many things deployed, and you're going to have plenty of opportunities to rename as you go without the consequences being huge. You won't have that many, like the scope of a rename is not going to impact that many resources. So if you do need to do a rename later, it's not as big of a deal. Yeah, if you're Google and you've already scaled up, the consequences of renaming a convention is probably dire because you've got thousands of everything, tens of thousands of everything. And so you really need to agonize over decisions like that. But when you're early in the startup phase and you're scaling out or you're looking at scaling out, you have a lot of opportunity to do experimentation. You can try out a naming convention, see how it works, and iterate on it. And so if you pull it back to where's the business right now, what's the actual problem I'm trying to solve, there's almost always a solution that will fall out of there in terms of how much planning do you really need to do.
Yeah, definitely. And the irony there is in DevOps, we talk a lot about cattle, not pets. You want your infrastructure to be deletable, redeployable. And as soon as you start naming your cattle, then it starts becoming a pet and you're not going to want to take it out to the pasture later on. And so it's better to just avoid that pain. So yeah, channel your inner Shia, just do it. And this next one that we've got is a plague and a curse: deleting abandonment development resources.
Yeah, so this is also a consequence of what I recommended earlier to get started iterating right away. That's going to mean you have to do more experimentation. You're going to have more laboratory environments. And those laboratory environments generate cloud spend if you're deploying in the cloud. And it can actually add up really fast. So early iteration will tend to lead to more spend if you don't keep those environments cleaned up. You're going to need lab environments at any stage. Like I did a DMS, an Amazon data migration experiment just the other day because like I was kind of sure from the docs how it worked, but I really needed to exercise it to be 100% confident. So you'll do it anywhere, but especially in that early stage, if you're focused on those iterations, you're going to do a lot of it. And keeping track of every test resource that you create is tough. You've got IAM roles and security groups and instances and volumes and clusters and VPCs and subnets and routing tables and network ACLs, and that's just like that's not even half. So trying to keep track of all that by hand and make sure it all gets cleaned up is pretty impractical. So one piece of automation that I recommend prioritizing from the start is a way to easily create and destroy laboratories. And there are three main ways that I know of to do this.
Yeah, and I guess when we're talking about cattle, sometimes you need to get in there and wrangle your cattle like a cowboy. We kind of got the theme going on. And this always reminds me of there's a good Dilbert comic that you're talking about like a bonus for every bug that you fix. In our case, it would be infrastructure deleted. And he's like, I'm going to write me a new minivan this afternoon. So, we get to write ourselves some minivans in this section.
Yeah, it's actually not that hard to do in a modern cloud. Like a lease payment's worth of cloud spend from development environments can happen after like 3 experiments or 1, depending on the sizing people pick. It happens pretty often. So in terms of ways to deal with this, the first one I'm going to kind of skip through really quick because I don't think it's super practical for startups, but I'll mention it because you'll see it around out there. And this is mostly about AWS and GCP. I think it'd be a little different. You can create temporary AWS accounts that you then just delete as soon as you're done with them and like do 1 per experiment or something. But accounts are pretty heavy resources. You need root users and SCPs and things, and managing a lot of them requires some fairly complicated automation, and there's other approaches. So this is more something that I would do after you've scaled up than I would do in the beginning when you're scaling. Kind of the next level from there is manually created developer accounts. Like, you don't necessarily need automation to vend accounts to do this. You can create one account for each developer, and you can run a tool like AWS Nuke, for example, will help you delete all the things in those accounts periodically, and you just kind of ping each developer one at a time, be like, hey, I'm going to delete your stuff by Friday, let me know if there's anything in there you need. And this is manageable for maybe up to 10 accounts, somewhere in that range. And it also kind of makes it easier to do things like share RDS instances and other resources that you may not need unique ones of in every environment. You can put some VPC peering in place to a central one and kind of have all your devs use the same database or something, and that'll help avoid spend on some of the more expensive resources like RDSs that tend to generate most of the cost. And then the third option, the next level up from that is to use the security features that are provided within accounts to create boundaries inside them. So you can use like IAM roles and security groups and naming conventions and tags and things to define boundaries within one account, and then you can use those conventions, the naming conventions and the tags and things, to keep track of resources that you create and delete them. This is nice because the boundary itself can be created in just like 2-3 minutes. You just need some security groups and IAM roles and stuff. It's not too hard to do, so the automation can be very fast. The total time, of course, depends on the resources you create. If you've got a Kafka and an RDS in there, it's going to take a while because those have to provision and deprovision, but the boundary itself is fast. It does take some nuanced automation to do this, but that automation is also exactly what you will need to go to production later. So it's not sunk cost to invest in this. It just gets you a head start on the structure and the boundaries that you'll need in order to deploy real environments. At Duplo, this is mostly what I do because there's some automation in the platform that does this out of box. That's how I did the DMS experiment that I mentioned. But you could also go through and write like some Terraform module for CloudFormation or something if you have the expertise on board to do that.
Yeah, this is all great. I had a manager once that was really adamant, and he had some great policies about how everything has to have a life cycle as well. So when you're talking about customer data, that life cycle could be very long, like 7 years. And if it's something like a microservice, it could have a year or two, but everything has to have some sort of time attached to it that it's going to be deployed. And if that ends up being your own dev virtual machine or something like that, then it could be a month, or if it just doesn't have one, then it gets deleted. And even if it's like in the case of customer data, then at the end of those 7 years, you're obviously not going to go delete that, but it makes you think ahead of time, how are you going to treat that data throughout that entire life cycle? Are you going to put that into different storage tiers so that you can save money? What storage tiers would those be? Does it need to be accessed ever? Things like that. And it keeps a lot of that temporary dev infrastructure that people deploy and forget about when they go on vacation from sticking around forever and ever. And I think we've all seen that, where they're years old VMs that nobody's touched in just as many years. So
right, and then are probably full of security holes at that point. Yeah, the focus on when do we delete and how do we delete is often a missing piece. Like, it's always about just what do we create, but if you have that focus on how and when do we delete from the beginning, then you'll end up with automation that can do that, and it'll save you probably significantly more than it costs to develop. Yeah,
got to get those minivans. And this is something that we do really well at DuploCloud. I've really appreciated that there's a focus on that frugality, both on our behalf and on behalf of our customers. And so it's good to have that mentality. And again, you're gonna be able to buy a team minivan when you're done with it. Gotta wrangle your cattle. And speaking of which, when you have cattle and you need to be wrangling it, you're also gonna have some sheriffs. So brings up our next topic, the confused deputies.
Yes. I haven't seen a Don Knotts movie in a hot minute, but yeah. So confused deputies are a general security problem. You'll find them in a bunch of places. I'm going to talk about them in the context of deployment automation. They're automated systems that have access to your infrastructure and can be tricked to do things that they shouldn't do. I'm mostly going to focus on CI/CD today. Your CI/CD pipelines will have some permissions to deploy, and those could maybe be abused to do the wrong things. But this also comes up with infrastructure as code orchestrators like Atlantis, which is like a tool that hooks Terraform runs into your pull requests. There's a bunch of similar tools out there. And this, like those, tricking deputized automation into doing the wrong thing can be malicious, or it can just be a mistake. Like it's not always about preventing breaches. It's partly about that. It's also about kind of constraining the blast radius of mistakes made by somebody who's trying to edit the pipeline. The first way that I deal with this is to use CI/CD controls that make sure that feature branch modifications to pipelines cannot run against prod. And before we get into that at a technical level, you've probably heard of the OWASP top 10 application security risks, like SQL injection and all that stuff. Well, the OWASP Foundation actually does a bunch of things. And one of the other things they do is maintain a top 10 list of CI/CD risks. And on that list, this is called poisoned pipeline execution, but it's the same thing. You'll see it go by a couple different names. So in GitHub Actions, for example, they have a thing called an environment. That's not just a generic term. It's a container that can hold secrets. So you can put like your AWS keys, or in my case, I'm putting a Duplo token in there because I'm looking for Duplo, but the keys that access whatever system you're using, you can put that in an environment, and then your pipelines reference that environment and get access to the key out of it. And you can put rules in that require specific users to approve each pipeline run before it can read the secret out of that environment. Then, no matter what feature branches anybody pushes that might modify the pipeline to do some other thing it wasn't supposed to do, like delete resources or whatever instead of update, the approval users will have an opportunity to review those changes before that pipeline execution can get access to the secrets that give it access to the resource that it was trying to delete. So it gives you kind of a stopgap. Like no matter what changes somebody might make, until that approval button gets clicked, it can't even get into the secrets. Sometimes folks will kind of bypass this because everybody in their repo is an admin anyway. And there are some edge cases where that makes sense. Like I worked with a really small team where growth was tied to physical locations that rarely changed. Like they had to get new buildings and stuff. And so they kind of knew when growth was going to happen. They had long lead time and they could get set up in advance if they needed to add more users or whatever. But in general, like I would recommend usually planning to restrict in advance if you're going to, like most startups have a kind of scaling goal where they're going to start adding a lot of people really quickly when they get another round of funding or something. And it's very difficult to put these controls in place while you're trying to onboard people who already need access to stuff. So I would recommend putting this one in from the very beginning. That example's for GitHub Actions. Most CI/CD systems have a way to do this, but the thing you want to watch out for is how do I make sure that nobody can bypass the controls just by pushing a feature branch that removes them. The next thing I do is to try to manage foundational infrastructure and application version updates separately. So this technique is more about helping you avoid mistakes. It's less of a security tool, but it's still a good thing to put in. So like you want to create your VPC and your RDS and those other base layer resources separate from publishing code changes. Like a really common thing that smaller teams will do is they'll use Terraform to deploy the bulk of the infrastructure, the clusters and the VPCs and the RDSs and all that stuff. And then they'll have a CI/CD job that runs somewhere and uses like kubectl or AWS CLI, or I use DuploCTL because I'm on Duplo, but whatever you're deploying with, to publish new versions to containers or Lambda function artifacts or whatever. And then you have separate systems, and you know that when you're running the CI/CD job that publishes new versions, it can't delete the database because it's not calling a tool that even knows how to do that. Like the script just doesn't have code for that, which makes it easier to kind of conceptually separate the risk level of running different things. Like when you start running the Terraform, again, you need to be really careful with the diffs. I maybe need to limit who I ask to do that to people who have a lot of context and things. But when you're just pushing app versions, you know that there's a much smaller set of automation there that just doesn't do as much. So the blast radius is lower.
Yeah, and everyone's going to take down prod at some point like that. That's okay. It's not great, but it happens. But you don't want to be deleting databases. That's
segmenting your automation like this will help a lot with avoiding that kind of problem. It just limits the number of ways that the mistakes on the daily can impact those base layer resources.
Yeah, definitely. Which brings up our next topic: drawing architecture boundaries, making sure those databases are safe.
Yeah, so as you start to build out more components, as you start to add things to your infrastructure, you're inevitably going to start to ask questions like who should have access to each resource and which resources should be updated as a group. And there's a bunch of different ways to come at this, but there's kind of two ways of thinking about it that I've come back to over and over in recent years. The first one is life cycles, and this helps protect you from like outages and data loss caused by mistakes and system failures. So you want to ask questions like, what should be destroyed together? Or my favorite way to look at it is, where can I lose data? If resources can be destroyed without data loss, if they're just like ephemeral compute resources like containers or something, then the worst that happens if they get deployed incorrectly or get deleted or something is an outage. And that creates a clear logical separation of risk. You have the resources that contain data where if they get deleted or misconfigured in some way, you might actually lose data, which is a big deal for most organizations because data is everything today. And then you have the resources that can, you just redeploy an older version or something and they'll come back up. And so this helps you decide where you need to draw different types of boundaries. So for example, a colleague of mine was working with a customer where that data was really high value and there was like only a limited set of people who should have access to certain parts of it. So they created what in Duplo is called a separate tenant, which is like our way to make a security boundary, but you can do it with security groups and IAM roles or however you do it. They put all the data resources in one tenant, and then they had separate tenants that had specific permissions to access that data through like connections to the RDS and things. And then they could give a more limited set of administrator users access to do things like delete those databases or manage the snapshots and other data retention. Sometimes you don't need a full security boundary. You might just need an operational boundary, in which case you can do something like use a separate Terraform module or CloudFormation template to manage your data resources and a separate one for your compute ones. That way, like, okay, if I'm running an apply in the data module or I'm running or an update on the data stack, that I need to be really, really careful because there's much bigger risk in that collection of resources. But if you're working on the compute ones, you know that you at least can't lose data because the data resources aren't even defined inside that module or stack.
Yeah, definitely. And it goes back to the whole idea of decoupling infrastructure, where a good system has things that are decoupled, that can run independently, fail independently, and it doesn't bring the whole thing down, doesn't bring prod down. So just a part of it.
Yeah, exactly. And the other way that I approach this can lead to some similar designs, but helps you look at it from a different angle, is line of business, like which resources contribute to delivering the same outcome for your customers. So this way is helpful for ensuring that like breaches and mistakes in one part of your system only impact one part of the business. For example, I worked with a customer that like bought another app, like they just purchased it from another startup, but it didn't really serve the same customers. It didn't access the same databases. It wasn't administered by the same developers. So there was really no need to deploy to the same infrastructure because there weren't any access requirements to connect them together because they did different things for different essentially business units that happened to be owned by the same parent company. And so it's easy to start thinking of your infrastructure as like a generic container for everything. But if you start looking at the business use of each app, you'll find places where that's actually not true. It doesn't need to be a generic container. And then that gives you an easy place where you can start putting in security boundaries and operational boundaries that constrain the blast radius of breaches or mistakes.
I think that there's really, like, if you look at infrastructure, there's a definite flow. You can kind of separate things by how well they flow together, and if they don't, if you're really beating yourself against the infrastructure trying to make it work, then maybe it does belong separately. So it's kind of a natural way to look at things too. Next up, we've got building deployable applications. So
this is a big topic, just like security is. I'll talk about kind of two of the most common things that I run into, and these are basically a couple of anti-patterns that just make it more difficult and therefore more expensive to deploy your apps. Like a great way to reduce your DevOps cost is to just have apps that are easy to deploy. The first one is backwards incompatible database migrations. So your dev teams will know about database migrations for sure. This is where, as your app code changes, you might need to add tables or add columns to tables or change the format of data stored in them. This is mostly for relational databases. And there'll be some kind of scripting or automation that will move the content of the database to migrate it to the new format. It'll change the storage formats, it'll rename the tables, do all those things. The thing is then, you end up in this situation where the new format of the database only works with the new version of code. But many, maybe even most modern deployment patterns and tools assume that you can run new and old versions side by side. Like rolling deploys are probably the most common deployment mechanism in containerized environments, where you've got a fleet of containers. It'll replace one of them at a time, make sure the new one comes up online healthy, and then move to the next one. But that means you've got the fleet running the old version, and then the replaced one's running the new version. Or canary deploys, which are common in high load environments where you have a ton of traffic. And so you'll have your fleet of systems, you add one more with the new version, and you kind of trickle traffic over to it for a while and see how that goes. But again, you have to run multiple versions of the application side by side. And there's so many different places where this pops up that avoiding all the patterns that can result in versions running side by side is a significant limitation. Like, that's really hard to work around. And so if you have backwards compatible migrations, then you just avoid all of that from the beginning. But the thing is, they're a habit that developers have to adopt. Like, to oversimplify, it's like if you need to rename a column, you create a second one with the same name and you put the same data in it, and then you keep them both there for a while, and then you retire the old one later. Like, there's a flow you have to go through, and it kind of depends on what you're doing. So there are development habits and reviews and things that your team will have to put in place. In some cases, that can be done quickly. Like, I worked with a team that adopted that practice in the middle of a migration, but there was only 2 people on that team, and it didn't really conflict very much with their existing habits. It can take a little more to get in place. And so if you build those habits from the beginning, it's just going to avoid a whole bunch of conflicts with common deployment automation systems.
All this talk about databases going backwards, like they're time traveling, just makes me think, you're talking about these databases, we have to go back.
Yeah, well, as a result, I will now name all of my databases McFly.
Approved. I'm approving that PR.
Good. I'll tag you on it. I'll tell everybody you said that.
I'll own it.
The next kind of common anti-pattern that I run into are singleton architectures. And so singletons are components that cause problems if you run more than one of them. Like, I worked with a team that had some Ruby Sidekick workers. Sidekick is the Ruby on Rails, like, asynchronous task processor. It sits in the background and handles, sending messages or whatever. And this one did send messages. It emailed out to customers, but it was built in a way where, like, it was consuming from a queue. And if there were 2 of the workers, and then one item comes into the queue, they would both read it, and then they would send duplicate emails out to customers. And so I'm mostly talking about situations like that where it's not safe to run them side by side. Like, there's some kind of end user visible problem. They get duplicate messages or corrupt something in the database or whatever. If running multiple side by side just results in the second one failing to start, or something that's like an internal problem that you'll see on your team, but it doesn't affect customers, that's not as bad. It's still not desirable, but it's not as big an issue. It's mostly about ones that aren't safe. They do corruption or something. And the thing is that for the same reasons that we talked about with database migration, it's hard to make sure that singletons never run in parallel, like guaranteeing that. It's really easy for it to happen accidentally, even if you know you're not supposed to do it. Like, for example, there's a sort of common diagnostic practice where if you have a fleet of systems and one of them is broken, you'll pull it out of the load balancer and stop sending it traffic and then start working on it. But if it's not a fleet, if it's just a singleton, you pull it out, you stop the service there, hopefully you remember to do that, and then the replacement comes up, and this one starts serving traffic. But now this one, you're doing diagnostics on it, and one of the most common to try to understand why it went wrong, while the other one serves traffic to minimize the length of your outage. This one that you're doing diagnostics on, one of the most common diagnostic tactics in the industry is to restart things after making changes. But you have to now make sure that your whole team knows to not do that and remembers to not do that at the right time. Otherwise, you end up with 2 running, and now you've sent multiple messages or corrupted the database or whatever. So the thing is that infrastructure tooling today tends to be built to avoid outages and scale horizontally. And singletons force you to avoid a lot of the common design patterns used to achieve those goals. So they're going to get in the way all over the place. If you can at least make your singletons safe to run side by side, but hopefully just not singletons at all, you're going to have a lot less trouble. There's a whole category of questions you can just skip right past, which means you don't have to pay your team to solve them.
Of all the things you want to scale out horizontally, you don't want your failures scaling out horizontally.
Yes.
Or your belly, but that's a different subject. The singleton, it reminds me very much, if DevOps were part of like royalty, it would be like Singleton Abbey. It reminds me of Downton Abbey. I don't know why, but
well, singletons can be expensive and a little bit difficult to deal with, so
true.
There may be some parallels in the metaphor.
True. And so, if Maggie Smith were a DevOps engineer, I think I could die happy, in an alternate universe. So, by the way, Singleton is a real place. So there is a Singleton Abbey, and now you know.
Right? It's you and me, Cameron. After we get rich, that's where we're moving. We're buying that place.
Done. I'd be cool with that. Well, in case you missed any of our key points, here are our key takeaways.
Yeah. So if you're stuck trying to make a plan for your DevOps work for your infrastructure, look for something you can start iterating on right away. You may end up having to change direction a few times and do a little bit of re-engineering, but you'll have the details you need to make the right decisions once you're hands-on with it. So it's worthwhile. It's still faster to get started right away and make a couple course corrections. Watch out for the fact that infrastructure automation has a lot of access. And that means that it can be tricked into doing things that damage your infrastructure and your product in general. So always audit it for ways that it can be either intentionally or just accidentally misused during updates. Look for the design of your infrastructure in the business value of your applications and the data that they store, not the tooling that implement it. So like instead of focusing in on things like VPCs and Kubernetes, think about what customers does this serve, what critical data is needed to serve those customers. You'll tend to find clear places where you can draw security and operational boundaries from those conversations. And then as you're building, watch out for application anti-patterns that increase DevOps costs, that just like make your apps harder to deploy. We covered two of them, but anytime you start thinking, oh, I can fix this in the infrastructure by doing X, Y, and Z, by writing some script or turning off, rolling deploys or whatever, pause there. Those are likely to be more expensive decisions than it seems like, and it's generally better to solve those problems in the application than in the infrastructure.
And don't forget, channel your inner Shia and just do it. And code yourself a new minivan in the process.
Yes.
And while we're talking about time traveling, make sure that you time travel straight to our next webinar, CI/CD the best. Kelly's awesome. You're going to love this webinar. And now we've got our questions. So put them in the chat, put them in the Q&A, and see where we can take advantage of Adam's expertise. He's a really knowledgeable guy. So put them all in the chat.
Especially when it comes to naming conventions. I mean, I got you covered with the fruit and the McFlies.
Yes. I will never not name a database McFly from here on out. All right, what questions do we have? Questions, thoughts, favorite fruit? Yeah, the Singleton stuff, is it Sergey? I don't know how to say your name, I'm sorry. That was something I hadn't heard about until we started prepping for this webinar. So yeah, really, really cool stuff.
Yeah, they can be kind of surprising. Like they're not too bad when you're doing local development or even when you're in like your first dev environment or something. But as soon as you start trying to load test or scale out, those things get in the way really fast. I've actually spent a good chunk of time trying to deal with them. Like the singletons, for example, at Duplo, we actually go out of our way to override some of the Kubernetes defaults so that rolling deploys don't create a new container first. They destroy the existing one and then create, which means now we have to like ask questions and interview your team and like understand if we can turn that back on. And we have to like add more replicas and things to work around it. So it's not something that's likely to come up in early development testing. It's more going to come up later. But if you just build your code from the beginning to not have those problems, then it ends up solving a lot down the road.
Yeah, and when something fails and you don't, you need to remember protocol and little details to get it back alive. Like that's the last time that you want to be worried about the little details. You want to have it just, it's like drilling, doing drills, like fire drills or whatever it is. You want to have that down, practiced, and ready to go.
Way back in IT, before DevOps existed, I had a mantra: any plan that depends on an operator remembering to do the right thing at the right time is guaranteed to fail. It will not succeed all the time. Like that can't be done. So if you have those kinds of problems where you have to remember to not do something like restart the one that you have held for diagnostics, somebody will someday. It's guaranteed.
Yeah, and I'll be the first to do it, guaranteed. Let's see. Oh, we got a new chat. True. All right, let's see. We got a question from anonymous user. Anon's in the chat. Have you ever seen a time where starting too soon and not enough planning comes back to bite you? So I guess on kind of on the flip side of everything we were.
That is a good question. I have. There are. So you do need to start. You do need to get those directions right. And another area that comes to mind that you got to watch out for is kind of understanding the scale of what you're doing. Like I saw one project that tried to start iterating right away, but they didn't do very much like kind of discovery with the team that they were working with. And it turned out that the application that they were deploying was actually only one of three. Like it was a bunch, it looked like the whole system to them because they hadn't worked with it before, and it had a whole bunch of components like multiple databases and microservices and everything. They're like, oh, this must be it. That was actually only one of three major parts of the system, which meant that their understanding of kind of how much work they had to do and how long it was going to take was off by a factor of 3. And since the timeline was months, you're nudging into the territory of a year. And so you want to make sure that you do enough at least to understand like the high level components that you have to deploy and the different like make sure you've talked to all the different senior leaders who have buy-in on this project and are expecting you to do something, and make sure that they have gotten you time with the senior and lead engineers in the teams that work for them. So you can at least make sure that you have like the names of all the people who are expecting things from you. And you can use that to at least understand where there might be like implementations you don't know anything about that still need to be done. And that'll help make sure that you can start breaking up the project. Like, okay, we're iterating on this one first, but you're setting expectations about the fact that the other ones aren't being touched yet. So you do need to make sure you do enough to understand the high level like buckets of work that have to be done. And that'll also help you watch out for things like some of those apps were implemented in entirely different languages and ecosystems, so that didn't really matter that much if they were done in a unified way, but a couple of them were all built out of the same platform. So you kind of needed to accommodate their differences. You wanted to build like one system that could handle both rather than building two bespoke systems that deployed something that was very similar. You didn't want to double your effort. So it'll also help you catch areas where you need to kind of make sure that your engineers are in communication with each other and they're all building to accommodate the different deployment patterns you'll need for whatever fleet of applications you're launching. That kind of stuff is a little more likely to come up at the enterprise scale. At the startup scale, you'll still see things like that happen, especially if you've got like a couple different business units, or like you've got like an AI ML component over here, and then you've got like a more traditional web application over here. Their system requirements might be pretty different and things. So just make sure that all the right senior leaders are involved so they can flag areas where anybody else is expecting other work.
Yeah, definitely. Nothing like getting to the end of a project and like, oh, we're just getting started. Like, what?
Yeah, the end of the project.
Yeah. And then, taking in, you need to reconsider architectural decisions because you weren't looking at the other half of it or anything. So yeah, definitely don't want to be doing that. So, well, thank you, Adam. Thank you everyone for being here. We really appreciate you. Make sure that you check us out on LinkedIn, send us a message if you have any questions or anything you want to chat about, and we'll see you on the next one. Thank you, everyone.
Thanks, Cameron. Thanks, everybody.